So, students, continuing with the chapter 1, Matter of Physics, we are on page number 4 again, and here we have Think and Discuss. The first question is, let us stretch a rubber band. Is there a change in its shape? So, in the previous page, we were discussing about the compressibility. Yes or no? So, when I take a rubber band in my hand and I'm going to, pull it apart, I can see that it is changing its shape. Why do you think it is changing its shape? Because of its elastic nature. And once you release it, it is going to regain its shape. The second one here is the rubber band solid or liquid? What do you think? You're able to hold it in your hand. Water, can you hold it in your hand and do compressibility on it? No. Can you just stretch water in your hand? No. So this clearly shows that rubber band is nothing but a solid. So now the third question here is, take some powdered salt, keep it in a jar. Which shape does the powdered salt take? So I have, drawn a jar over here, and I have put some crystals. So you see that the powdered salt is going to take the shape of the container. You can do it in the kitchen also. Whenever you're going to open the packet of salt, and pour it inside or put it inside your salt box, you will see that the salt is going to take the shape of the container. From the previous videos, we know that liquids take the shape of the container. So does this mean that salt is a liquid? No, it is not a liquid. Then why is it taking the shape of the container? Because it is really tiny. The salt particle is really small, and when as you drop it inside the jar or the container, it is going to take the shape of the container. Okay, this doesn't mean that it is a liquid. It does not flow like liquid. Okay, so here the fourth question is, take a sponge. We have used sponge in our schools and all. You must be having sponge at home. It is a yellow rectangular spongy structure. So now, can you compress it? Yes, when you squeeze the sponge, you can see it is changing its shape. Yes, we can compress sponge. So why do you think you can compress sponge? Because it is light. Yes or no? When you hold a sponge in your hand, it is much more lighter than a duster. So now a sponge is also a solid. We know that solids do not have a good compressibility rate. Then how are we able to compress the sponge? That's because the intermolecular distance in a sponge is much more lesser when compared to a wooden block. If I take a wooden block in my hand and if I take a sponge in my other hand, I know that I'm able to squeeze the sponge much more easier when compared to the wooden block. That is because, as I mentioned, it is all because of the packaging of molecules in both the solids that I have mentioned over here. One being sponge, the other being wooden. And in sponge, it is, quite lighter when compared to the wooden block. The intermolecular distancing in a sponge is, much more when compared to that of wooden blocks. So here, that's the reason you're able to compress sponge and you're not able to compress the wooden block. Okay. The fifth one being, why can't you compress a wooden block? I've already answered this, but still we will discuss this one. Why can't you compress a wooden block? You hold a wooden piece in your hand from the syringe experiment. It was case 1, case 2, case 3. In the third case, we were holding a wooden piece in our hand and we were trying to press it from both the ends. Is the wooden block changing its shape? No. Is it compressing or squeezing? No. Why do you think? Because it is a solid and it has tightly packed molecules. The intermolecular distance is really, really, good in is really less. It is lesser when compared to that of a sponge. The spacing is tighter. They are compactly packed with each other, the molecules placed inside a wooden block. For example, if this was the molecular arrangement of the wooden block, the molecules would be really close to each other. Okay, as I'm showing you as an example over here, this could be the molecular arrangement of a wooden block where the molecules are very close to each other. Okay, whereas in a sponge, they might be having a certain distance in them. Okay, they might be close, but not as close as the wooden block. Okay, so that's the reason you're able to squeeze the sponge much more easily when compared to that of a wooden block. Okay, thank you.